is infinity. And same manner, any of you can say, what is the sin z expansion? Z minus z cube by factorial 3. I know you people will not say anything because you people are very quiet students. So even if we ask your name, you will be quiet. I know. So for modulus of z is less than infinity, same manner, cos z expansion. Cos z equals to 1 minus z square by factorial 2 plus z power 4 by factorial 4 minus and so on. Sorry, here also minus. Here also it is minus only. For this expansion also exists for modulus of z is less than infinity. Okay, main formulas only I am going to explain now. 1 by 1 minus z. If I take 1 by 1 minus z, how we can write it is as 1 minus z whole power minus 1 form. What is the 1 minus z whole power minus 1 formula? 1 plus z square plus z cube plus z power 4 plus and so on. Okay, this expansion exists for modulus of z is less than 1. So students, all of you know that these formulas, sir, ivanni maagochu sir, enduku cheptunnaru. The formula you know it, but whatever I am writing, this expansion is valid for modulus of z is less than 1. That is important. So that's why I'm explaining this, and all these formulas we are going to use, especially these two formulas we are going to use in most of the problems. 1 minus z plus z square minus z cube plus and so on. For this expansion also exists for modulus of z is less than 1. Okay, so these are the things. So same manner, you know how to write the formulas of 1 by 1 minus z whole power 2. What is the formula of this? 1 plus 2z plus 3z square plus 4z cube. All these are your intermediate formulas only, and might be used in few concepts of our engineering. That means your engineering course. So same manner, 1 by 1 plus z whole power 2 is equals to same terms what are existing in the previous formula, but the signs are alternative signs. 1 minus 2z plus 3z square minus 4z cube plus and so on. For modulus of z is less than 1. So with this, I'm going to stop the formulas. So all these are formulas, you know it already in your intermediate. Okay, but now here, the main thing is there are two theorems in this complex power series that are, one is Taylor's theorem and another one is Lorentz theorem. I'll just write the main formula, but sometimes they may ask for 2 marks, state the Taylor's theorem. State the Taylor's theorem. In that case, you people has to be in a position to write the statement. The statement and both the statements, I'll post it in the website. But statement, okay, mainly we have to concentrate on the formula. So I'm just writing only the formula on the screen. So f of z equals to f of a plus z minus a into f dash of a plus z minus a whole square by factorial 2 into f double dash of a plus and so on. So if we go like this, z minus a whole power n by factorial n into nth derivative of f of a plus and so on. So this is a Taylor series expansion of f of z, and especially in this, we can write this one in the form of summation. F of z can be written as summation n is varying from 0 to infinity, z minus a whole power n by factorial n into nth derivative of f of a. Now, expand this, how you will get it? Are you going to get the previous, the main formula which I given? Check it, you will get the same. So same manner, I'm giving you the formula for the Lorentz also, but I'll discuss both the problems combinedly. Lorentz theorem. But compare with the Taylor's theorem, Lorentz theorem statement is very, very important because the statement itself will take nearly half page, nearly 10 lines, 8 to 10 lines. So Lorentz theorem, just I am writing as a statement. Okay, I am writing only the formula. F of z equals to summation n is varying from 0 to infinity a n into z minus a whole power n plus summation n is varying from 1 to infinity bn by z minus a whole power n. I'll tell you what are the difference of that one and this one. So wait for a few more minutes, and we are not going to concentrate much more on these formulas, but I will try to explain these formulas clearly later. So where an is equals to 2 pi I circulation integration over C1 f of z dash by z dash minus a whole power n plus 1 into dz. N plus 1 into dz. Sorry, dz dash. And I'll explain the problems without using these formulas. But why I'm giving these formulas are, these formulas will be useful for us in the next concept. After completion of problems on this model without using this, I will explain how to, after completion of problems, you can understand how to recognize these are the formula of this, these are formula of this or something. Okay, so just for the namesake, I'm giving you these formulas. Okay, so now going to start problems. Without learning the concept of Taylor's and Lorentz also, you can find out. But for that, we require only one point is important. The point is the expansions what I explained on the top first before I'm going to start this class. That are the things are important for us. Okay, so now going to start problems. First, I'll start with the ABCD problem. It means easiest problem. Obtain the Taylor series expansion of and the topic is very, very easy, but only thing is one point you have to understand, that we will discuss Taylor series expansion of f of z equals to 1 by z about the point z equals to 1. About the point z equals to 1. So you have to concentrate on here this wording about the point z equals to 1. Whenever they will give about a point z equals to 1, you might be learned in your LAC subject Taylor's series. Okay, Taylor's theorem. In the Taylor's theorem, there are three formulas: Maclaurin series expansion, f of z expansion at z equals Maclaurin series expansion of f of x at x equals to 0, and one more, Taylor series expansion of f of x at x equals to a, Taylor series expansion of f of x about x equals to a. Okay, so in case of about x equals to a, what you learned already, we have to consider. So we need to find first writing given f of z equals to 1 by z. So anybody can say, whenever they are providing about z equals to 1, what to do? Okay, so whenever they mention about z equals to 1, In that case, take z minus 1, bring that right hand side one also to left hand side, we will get z minus 1 is equals to a new variable w. Then later, whenever we required, how we can write z is equals to take left hand side minus 1 to right hand side, it will become z plus, sorry, w plus 1. Okay, so now substitute it in our f of z function. What is f of z? 1 by z. What is z is equals to how much? What is the value of z here in terms of w? What we have?
W plus.
W plus 1. So now you observe how it looks like. 1 by, how it looks like? 1 plus w. 1 by 1 plus w. Now check the formula of, what is the formula of 1 by 1 plus z? What is the formula of 1 by 1 plus z here?
1 minus z plus z.
Minus z plus z square minus z cube and so on. This expansion will exist for this region. But in place of z, what we have? W. So what we are going to write now? 1 minus w plus w square minus w cube plus and so on. For all modulus of w is less than 1. So that we are going to get in place of in our problem. So writing this is as is equals to 1 minus w plus w square minus w cube plus and so on exists for this expansion exists for modulus of w is less than 1. Then replace w. What we have to replace with w value?
Z minus 1.
Z minus 1. Replace w equals to z minus 1. How we got it? That only we have taken. Okay. So that implies f of z is equals to 1 minus of z minus 1 plus z minus 1 whole square z minus 1 whole cube plus and so on. This is the Taylor's series expansion. Is the Taylor's series expansion of Taylor's series expansion of what? F of z equals to 1 by z. And this expansion exists. This expansion exists only in the region. This wording is important. Only in the region. Now tell me. So here modulus of w is less than 1, but that modulus of w in place of w, what we are replacing? Z minus 1. So modulus of z minus 1. So this is the region. This expansion is a valid expansion only in this region, no other region. ఈ రీజియన్లో మాత్రమే ఎగ్జిస్ట్ అవుతుంది. నువ్వు మీ ఇంట్లో మాత్రమే బాస్. మేబీ నువ్వు చెప్పింది జరుగుతుంది, కాలేజీలోకి వచ్చాక నువ్వు చెప్పింది జరగదు. ఓకే, సో ఎగ్జిస్ట్ ఓన్లీ ఇన్ ద రీజియన్. Modulus of z minus 1 is less than 1. This is a proof of our problem. That means a solution of our problem. Okay, any doubt? Sir, how can I mention it is as a Taylor series expansion? Why I mentioned it is as a Taylor series expansion? So now you check in the right hand side part of our this part. How we got the right hand side part? In powers of z minus a. In powers of z minus a. What is a value here? It is 1. So what is the Taylor series expansion? This one only. Summation n is varying from 0 to infinity, z minus a whole power n by factorial into z, nth derivative of f of a. What is that nth derivative of f of a? That all is our function. Function ki differentiate cheyadam anni ayipoyin tarvata vachede expansion. So we are able to write f of z equals to 1 by z about the point z equals to 1 in this expansion. So we can say it is as a Taylor series expansion of the given problem. Okay, now same manner I am giving you for practice. One problem is find expansion of e power z about z equals to 1, about z equals to 1, and say what is about z equals to 1. What you have to do here again? Anybody can say?
Z minus 1 is equal to W. And
so take again z minus 1 is equals to W and substitute it in e power z. In place of e power z, what you will get? E power W plus 1 you will get. So e power 1 into e power W. E power W expansion already you know. So the total expansion is exist only for modulus of W is less than infinity. So W is nothing but replace W, modulus of z minus 1 is less than infinity. In this region only the expansion whatever you are going to write will exist. Okay, so hint I am writing here. What is the hint? Take z minus 1 is equals to W, and this is the region we are going to get. Okay, final region. In this region only our expansion will exist. Same manner, giving a problem, one more problem for practice. Sin hz. What is the formula of sin hz? Is it I given the formula of sin hz? Is it I gave you the formula of sin hz? No, but you people know the formula of sin hz. Same sin z formula you will get in place of sin hz also, but all the terms are positive. Okay, is it clear? All the terms are positive, so you do that. And this is about z equals to pi I. Z equals to pi I. So one problem I gave you for your practice. Okay, going for a little bit typical problems. So third one is expand f of z equals to z minus 1 by z plus 1 in Taylor's series. About the point in this again I am giving two things, z equals to 0 and the second one is z equals to 1. Now tell me which one you want me to explain. Either z equals to 0 or z equals to 1. Which one you want from my side? Z equals to 1 or z equals to 0? Which one you want me to explain?
0, first one.
So about z equals to 0. Okay, right. Good. So why you have chosen z equals to 0? Because already z equals to 1 we discussed. So in this case we have to take z minus 1 is equals to what you call W, like that we have to convert everything is in that form of this thing. Okay, now they given z equals to 0, nothing but bring right hand side 0 also to left hand side, it will become z minus 0 equals to W. So there is no use of taking a new variable, so that I'm not taking any new variable here in case of about the point z equals to 0. So I am writing here given f of z equals to z minus 1 by z plus 1. Now what I am going to do is I am going to write this is as two different terms. Instead of writing two different terms, okay, I am treating it as a minus b by c. How to write a minus b by c? A by c minus b by c form. Z by z plus 1. So z by z plus 1, we are not having any formula, but we are having formula for 1 by z plus 1. But we are having formula for the second term. So that what I am going to do is, I'll try to bring the numerator also z plus 1. So how I can bring the numerator also as z plus 1? I'm adding and subtracting with 1 in the numerator. Then what we will get? Like this only. Yes or no? Now use a minus b by c formula. If we use a minus b by c, what we will get? Z plus 1 by z plus 1 minus 2 by z plus 1. If you do the simplification under LCM and simplification, again we are going to get our function only. There is no changes, anything. But why I am doing like this? The reason is, if we are not having any expansion for z minus 1 by z plus 1, so that doing like this. What is the first term is going to become? That implies f of z will become as, first term will become plus 1 minus 2 into 1 by z, 1 plus z, 1 by 1 plus z, 1 plus z. What is the expansion of 1 by 1 plus z?
1 minus z plus z square minus z
1
cube.
minus z plus z square minus z cube plus and so on.
So,
We used this is a nearly second time. In the second problem, again we are using it second time, and this expansion exists for modulus of z is less than 1. Okay, so you do some simplification, then what we will get? F of z equals to 1 minus 2 becomes as minus 1. All the terms multiply with minus, then plus 2z minus 2z square plus 2z cube minus and so on. So this expansion exists for modulus of z is less than, modulus of z is less than 1. So this is the Taylor series expansion. How can we say it is Taylor series expansion? Check, all the powers of z are positive. All the powers of z minus a are positive, then it is Taylor's. Wherever we are getting Taylor, wherever we are getting negative powers of z or z minus a, it is a Lorentz. Negative powers of z or z minus a, then it is called as Lorentz. Okay, so can I go to next problem? Is it I am using any difficult things? If anything, you can post in chat, because you people are very quiet and calm students. You will not ask any doubt, you will not ask any question, you will not respond for any of the things which are asked by the faculty. I know it. Find the Taylor series expansion of, you can post in chart at least. Taylor's series expansion of find the Taylor series expansion of 1 by z square plus z minus 6, z square plus z minus 6 about point z equals to minus 1, z equals to minus 1. So now any idea how to do this one? Any idea how to do this one? As with my explanation in this till now, what we have to do? ఇక్కడ నేను మీకు చెప్పే ప్రతి ప్రాబ్లంలో ఒక్కొక్క కొత్త పాయింట్ నేర్చుకుంటూ ఉంటారు, అంతేగాని ఆల్ ద ప్రాబ్లమ్స్ ఆర్ డిఫరెంట్ సార్, సో ఐఎమ్ అనేబుల్ టు అండర్స్టాండ్, నో. సో ఫర్ మోడల్ ఐఎమ్ గివింగ్ one thing. Okay, you are not asking anything, is nothing but, so I'll go with the
Sir,
yes.
Sir, in the third sum, for z equals to 1, should we not consider z minus 1 equals to omega? I mean W.
Which one?
For z equals to 1. Third question, second bit.
Third question, second bit, for z equals to 1, about z equals to 1 is there. So we have to consider double z minus 1 is equals to w, we have to consider. If we consider this, then what is f of z is going to become as numerator is w and the denominator is w plus 2. So how to write, do we have any formula expansion for w by w plus 2? Do you have any formula for this in our expansions? No. So that add and subtract with 2 in numerator, w plus 2 minus 2 by w plus 2. So use the formula like what we did here, same process, you apply that, then it will become 1 minus 2 by w plus 2. So now again 1 by w plus 2 form. So use the same formula what we discussed here, but right. Yes, correct. Good question. So I'm going to clear this. I'll explain this one also. Okay, just wait for a minute. I'll discuss this problem later. So what we are doing here, f of z equals to z minus 1 by z plus 1 and replacing in terms of w, then we are going to get 1 minus 2 into 1 by w plus 2, like this we are getting. But we are not having any formula for 1 by 2 plus z or 2 plus w. So that we have to reduce the denominator part in the form of 1 plus w form, 1 plus something form. So taking 2 common in the denominator, while we take the 2 common in the denominator, then we are going to get like this. Then if you observe, this is like 1 by 1 plus z formula. So this expansion exists for which one? Exists for which region it will exist? 1 by 1 plus z expansion exists for modulus of z is less than 1. But in place of z, what we have here? W by 2. Modulus of w by 2 is less than 1. Okay. So now replace w. What is w? Z minus 1. That implies f of z equals to. So now if you do simplification here, 1 and minus 1 gets cancels. So what about the remaining terms? We'll get all the remaining terms has to be multiplied with minus 1. So we will get w by 2, replacing with the w. W equals to z minus 1 by 2 minus z minus 1 by 2 whole square by 2 square minus 1 by 2 cube into z minus 1 whole cube. This is plus z minus 1 whole cube. What is the next term we will get? Minus 1 by 2 power 4 into z minus 1 whole power 4 plus and so on for region. Now here actually what is this? How I can write this? Modulus of w is less than 2. But in place of w, substituting z minus 1. So it will become modulus of z minus 1 is less than 2. So this is the region. Is it clear? Your doubt? And this expansion exists for this region. Modulus of z minus 1 is less than 2. So is it clear to everyone? No. We are not having an expansion for this. So what we have to do is write the denominator as factors. So they didn't mention it is as a f of z function. So let f of z equals to 1 by z square plus z minus 6. Do we have any factors for the denominator? Can we write it as a factors?
Yes, sir.
What is that?
Z plus 2 and z minus 3.
Z plus 3 into z minus 2. Antana? Chudandi. Z square plus z minus 6. Yes. If you want, you find out. Okay. Because of the lack of the time, I'm going a little bit fast, not much fast. So now I'm going to write in our Laplace transformation, I discussed a concept in inverse Laplace transformation. So wherever you are having a partial fractions, okay, wherever you are having a fraction like this, we have to use the partial fractions. How to write the partial fractions? Guessing method I used. What is that? What is the thing we can use here? Okay, 1 by z plus, z minus 2 minus 1 by z plus 3. What is the LCM of this? Z minus 2 into z plus 3. Okay, we are getting it. Numerator becomes z plus 3 minus of z minus 2. So what we'll get? 5 is the numerator. So what we'll get? 1 by 5 into, check the partial fractions. I'm not going in detail, students. So check the partial fractions. So meeting is closing. Please rejoin with the same link. If the meeting closes, 1 by z minus 2. Do we have any formula for this? No. Do we have any formula for 1 by z plus 3? Then what we have to do? What we have to do? Any idea?
We'll split it and take common against the previous problem.
What is the previous problem? What is that point?
We'll write z minus 2 as z minus 1 minus 1.
Wait, student. I made a mistake. What is the given function? This is a function. At which point, about which point they are asking? Z minus 1. So this is wrong what we did. I missed this point. So what we have to do is, we have to go with the replace z minus of minus 1. What is the z minus of minus 1? Z plus 1. We have to take with w. Enduku? Because of that is a point they given as a about the point they mentioned in the problem. So again repeating this, whatever I discussed till now is wrong for this problem only. Okay. So finding Taylor series expansion about z equals to minus 1. Whenever about z equals to minus 1, so take or consider or put z plus 1 equals to w. That implies z equals to w minus 1. Now substitute this in f of z function. Therefore, f of z becomes like this. What is f of z? 1 by z square plus z minus 6. In place of z, what we have to take? W minus 1. So what we'll get? 1 by w minus 1 whole square plus of w minus 1 minus 6. So if you do the simplification in the denominator part, what is the a minus b whole square formula? A square plus b square minus 2ab plus w minus 1 minus 6. It is, everything is 1 by w square minus w minus 6. Unfortunately, we are getting similar banner, but it is a z square plus z minus 6, but here it is w square minus w minus 6. So now rewrite it is in the form of factors. What are the factors we can write? In the w minus 3 into w plus 2 we will get it. So similarly we got, but thing is different. Now writing it is in the form of partial fractions. So using partial fractions, use partial fractions. By using partial fractions, we can write it is as, okay, 1 by w minus 3. Okay, 1 by w plus 2. So after simplification, w plus 2 will come to the numerator. Minus of w minus 3 becomes as 5. 1 by 5 వస్తుంది కదా. ఒకవేళ ప్లస్ పెడితే ఏమవుతుంది, మనకి w క్యాన్సిల్ అవ్వదు, అందుకని మైనస్లే పెట్టాలి ఇప్పుడు. సో దిస్ ఈజ్ f of z. But how to write? Sir, left hand side is a function in terms of z, right hand side is no z, but it is in terms of w, but w is in terms of z. Okay, so now writing the right hand side part like this, f of z equals to 1 by 5 into, do we have any formula for 1 by w minus 3? No. So in that case, what we have to do, I discussed in last problem. What we have to do? Please respond.
Take the terms.
Take the total constant term in the denominator. What is the constant term? Minus 3. Taking minus 3 common. If we take minus 3 common, we will get 1 minus w by 3 minus 1 by, same manner, take 2 common, 1 plus w by 2. Okay, so be careful while you are mentioning the brackets. 1 by 5 is common for both, so minus 3 by 5 into, what is expansion? Okay, what we will get? 1 by 1 minus w by 3. This expansion I will do it in the next step. Plus, sorry, minus 1 by 5 into 2, 1 by 10 into 1 by 1 plus w by 2. Is it clear to everybody? Now, tell me, what is expansion?
Minus 15.
Sorry, yes, correct. Thank you. So this is minus 15. This is not minus 3. This is a minus 1 by 15. Minus 1 by 15. Minus 1 by 15 is this. Now, minus 1 by 15 into, okay, now minus 1 by 15 into, inside the brackets, what is expansion we have to take? 1 by 1 minus z. What is expansion of 1 by 1 minus z? 1 plus z square and so on form. So 1 plus z is w by 3 plus z square, w by 3 whole square, z cube, w by 3 whole cube, plus and so on. But this expansion exists for modulus of z is less than 1. In place of z, what we have here? W
by 3.
Modulus of w by 3 is less than 1. Okay, minus 1 by 10 into. What about the second term? 1 by 1 plus z form, w by 2. Okay, 1 minus z, w by 2 plus w by 2 whole square minus w by 2 whole cube plus and so on. And this expansion exists for which region? Second term expansion exists for
Modulus w by 2 less than 1.
Modulus of w by 2 is less than 1. Okay, so same manner exists for modulus of w by 2 is less than 1. Don't do any simplification, students. Don't do any simplifications. Can I write this one as modulus of w is less than 3? And from this, can I write it as modulus of w is less than 2? Now replace w with what we considered, z plus 1 equals to w we consider. Check it out. About z equals to minus 1 we are finding. Yes. Z plus 1 equals to w. That w I am replacing. Replace w equals to z plus 1 here. So if we replace this, what we are going to get? That implies f of z equals to minus 1 by 15 into 1 plus 1 by 5 into z plus 1 plus 1 by 3 kada? It is 1 by 3. This is 1 by 3, not 1 by 5. 1 by 3 into z plus 1 plus 1 by 3 square into z plus 1 whole square plus and so on. Minus 1 by 10 into 1 minus 1 by 2 into z plus 1 plus 1 by 2 square into z plus 1 whole square minus and so on. Now I am writing both the regions at a time. This first term expansion exists for modulus of z plus 1 less than 3, and second term exists for modulus of z plus 1 less than 2. So the total expansion exists for okay, this is the thing. Now we have to combine both the regions. So now I am drawing a circle equation. Before I am drawing, I am taking xy plane. In this xy plane, where is our z plus 1? Z plus 1 is nothing but center of the circle is minus 1 with the 2 units distance. So I am taking, this is the center of the circle with the 2 units distance, and same manner I am taking one more circle, sorry, this is with the 2 units like this one, and again I am going to draw one more circle with the center same minus 1 but with the 3 units distance, Okay, now this is one is 2 units distance, and assume that another one is 3 units distance. What is the center? This is the center, minus 1. Now please try to understand what I am drawing here. So here I am taking yellow color. What is modulus of z plus 1 is less than 2? Modulus of z plus 1 less than 2 is nothing but, what is the region we will get? Inside the inner circle, yes or no? Less than 2. But whenever they are asking modulus of z plus 1 is less than 3, modulus of z plus 1 is less than 3, what is that region? Inside the outer circle. What is the combined region with both the shadings? What is the combined region of both the shadings? Modulus of z plus 1 is
less than 3.
Less than 2. Combined.
Yeah, 2.
Intersection part take. Okay. So always in this case we have to take intersection part. Inkokati untadi. Less than annappudu intersection part తీసుకోవాలి. Greater than annappudu outer section. That means union తీసుకోవాల్సి ఉంటుంది. Okay. Therefore the above Taylor series expansion, otherwise the above and రాయకూడదు. Therefore this Taylor series expansion exists in the region modulus of z plus 1 is less than 2. This is very, very important. You are not supposed to write both the regions. and modulus of z plus 1 is less than 3 will not satisfy. Less than 3 తీసుకుంటే, for example, if I take less than 3, then what is going to happen is the second series expansion, second term expansion will exist. Yes or no? No. In between 2 and 3, that means in this middle part, the second term expansion will not exist. Will not exist. So because of that reason, we have to take always intersection part. Intersection part. So this is the Taylor series expansion. Okay, still 5 more minutes are there. So any doubts, students? Any doubts, students? I know you people will not have any doubts. I think 5th problem or 6th problem. I'm writing the 5th problem. If any doubts are there, then you can ask. And don't leave, don't leave. Sir, z equals to 0, 1 can explain. Can you explain again? Okay. For z equals to 0, about z equals to 0, what we have to do about z equals to 0 is nothing but wait for you people. Some student asked me, so wait for a minute or twice, 2 minutes. I'll write a problem. Then if any student are having any doubt with it, then they can ask. Obtain the Taylor's series to the function z square minus 1 by z plus 2 into z plus 3. How to do this one? In the region is it they provided about z equals to 0 or z equals to 1 or z equals to 2? Anything here they mention? Yes or no? They didn't mention any point about any point. So in that case, what we have to do? We have to concentrate on the region. Region contains in powers of z. So center is 0. So about z equals to 0 only we have to do. So about z equals to 0 is nothing but take actually about z equals to 0, as one of the student asked in the chart. About z equals to 0 is nothing but here we have to bring 0 to left hand side, then you will get z minus 0 only. So take z minus 0 equals to w. Nothing but z equals to w. What is the use of taking z equals to w again? So don't go for this. Directly solve the problem in terms of z. No need to go for introduce a new variable w. Is it clear? The person who asked in the chat box. And any other doubt here? How to do this problem? How to do this problem? First of all, we have to find the fractions, partial fractions. For finding the partial fractions, how can we find the partial fractions here? What is the highest power of z in numerator? 2. What is the highest power of z in denominator? Is also 2. Then what to do? For getting the partial fractions, take the denominator, simplify it, then what we will get denominator? Sorry. I made a mistake here. It is denominator contains z plus 2 into z plus 3. This is z plus 3. Z plus 2 into z plus 3. Z square plus 5z plus 6 you will get it. So divide z numerator part with the denominator. Divide z square minus 1 with the denominator part. What is the denominator part? What is the denominator part? Z square plus 5z plus 6. Okay. So with that one you have to divide. General division cheyalsi untundi. Okay, I'll write one more problem. మీరు ఎటు డౌట్స్ అడగర్లే నాకు తెలుసు. You are good students. You will not listen anything. And also you will not get any this thing. Obtain Taylor series obtain for 1 by z minus 1 into z minus 3 in powers of z minus 4 and determine the region of convergence. Okay, so any doubts are there, then you can ask, otherwise you can leave. The region of convergence is nothing but whatever the last point we are getting in each and every problem, modulus of z minus 4 is less than something, that is the region. In that region only it is existing. It is existing is nothing but convergent. Any doubts are there, then you can ask, otherwise you can leave.